everyone. So as I promised, I make this video presentation as a continuation of our topic about the applications of theorems. So since I already discussed the example 1 and example 2, I will proceed now to example 3. So given this figure, in example 3, we are using the theorem of 15. So theorem 15, it stated that the measure of angle formed by two tangents of a circle intersect at a point in the exterior of the circle is 1/2 the absolute value of the difference of the measure of the intercepted arc. So if the angle P is equals to 75, given in problem A, our angle P is 75. And then let us find now the measurement of our arc AB and then the arc ACB. Since we are using the theorem 15, let us use the formula of it. So angle is equals to 1/2 times the measurement of arc minus the measurement of our other arc. So since our angle P is 75, it's already given. Let us find now the two value of arcs, the arc AB and arc ACB. But first, let us find the value of our arc AB. So which is 75 here. Let us put 75. This one. And then 1/2 times 360, which is the value of the whole circle. Then the measurement of our arc AB minus the measurement of our arc AB. Since our arc AB here is unknown. Now, to find the measurement of our arc AB, let us multiply both sides by 2. So 75 times 2 is 150. And then is equals to 360 since 1/2 times 2 is already 1. And then 360 minus 2 to the measurement of our arc AB. So how are we gonna find the measurement of our arc AB? This one. So let us divide both sides by 2. So 150 divided by 2 is this one. We get 75 is equals to 180 since 360 divided by 2 is 180 minus the measurement of our arc AB. And then our we already have 180 minus the measurement of our arc AB is equals to 75. Now let us transfer 75 here. 180 minus 75 is equals to 105. Now we already have the value of our arc AB, which is 105. So let us proceed to find the value of our arc ACB. So we're gonna do is that since the whole circle is 360 minus the 105, since the measurement of our arc AB is 105. So 360 minus 105 is equals to 255. So now we already have our measurement of our arc ACB, which is 255. Now let us proceed to our problem B, which is if the measurement of our arc AB is 75 here, this one is 75. Now let us find our angle P. So our angle P here is since to find the measurement of angle, we need the two value of arcs. Then wala man ta kay value sa isa ka arc. So the great thing to do here is that since 360 is the measurement of a whole circle minus the measurement of our arc AB, which is 75, let us minus the 360 minus 75 to get the measurement of our arc ACB. Arc ACB is 6. So to find now, we already minus, so we already have the value of it. So let us proceed now to find the value of our angle P. So 1/2 times the measurement of our arc ACB, which is 285. And then minus 75, which is the value of our arc AB. So 285 minus 75 is equals to 210. So 210 times 1/2 is equals to 105. So now our value of our angle P is 105. So let us proceed now to example 4. Now in example 4, we are also using theorem 15, and theorem 15 is already discussed by Ma'am Diane. So here we're gonna apply theorem 15 in example 4. So we have the problem. The line CB is tangent to the circle O at B, and second segment CA contains O, the center of the circle. So this one. If the measurement of our angle C here, our angle C is 40, then find the measurement of our arc DB and the measurement of our angle ABE. So first, let us find the measurement of our arc DB, which is this one. So we are using the value of our angle C, which is 40. Then we are using 180 since here in the problem, we have a second segment line, which is CA. So 1/2 times 180 minus the measurement of our arc DB minus the measurement of our arc DB. So 40 is equals to 1/2 times 180 minus 2 to the measurement of our arc DB. So 40 is equals to 90 since divide by 2 equals to 90, and then the measurement of our arc DB. So 90 minus the measurement of our arc DB is equals to 40. So let us transpose 40 here in 90. So 90 minus 40 is equals to 50. So we already have our value of arc DB. Now, let us find the value of our arc AB. This one. To find the value of our arc AB, let us minus the value of our arc DB, which is 50, to this line segment, which is 180. So 180 minus 50 is equals to 130. Now, because we are finding the angle of our ABE. So, we already have the value of our arc AB and arc, which is arc AB. So, the measurement of our angle BE is equals to 1/2 times the measurement of our arc AB, which is 130. So, is equals to 65. So, this angle values 65. Okay, let us proceed now to our example 5. In example 5, we are using now the theorem 18, which is stated that if two chords intersect within a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segment of the other chord. So in here, in problem A, we already have the value of our PC. line PC, which is 20. And then in PD, we have 10. And then in PB, we have 8. So let us find the value of our line AP. In order to find the value in our AP, AP times PC is equals to PD times PB. So, 1. Since we already have the value of our PC, which is 20, and then the value of our PD is 10, times the value of our PB, which is 8. So, AP times 20 is equals to 10 times 8. So 10 times 8 is 80 divided by 20 is equals to 4. So our AP is 4. Now let us proceed to our problem B. In problem B, the given is that PC PC is 10. It's 10. And then our DB, which is this one, is 24. And then our AP is 8. So now, let us find the value of our PB. So given that our AP is 8 times the value of our PC, which is 10, is equals to 24, which is the value of our line DB minus PB times PB. So PB times PB is PB squared minus PB times 24 is 20, minus 24 PB plus 8 times 10 is 80 is equals to 0. So let us use the factorial method. So let us factor PB minus 20 times PB minus 4. So it's equals to 0. After this, let us equate PB minus 20 to 0. So PB is equals to 20 and PB is equals to 4. So we already have the two values of our PB, which is 20 and then 4. Now let us proceed to our problem C. Okay, so given that our AP, this one and this one, PC is equal. So given that our PB, okay, our value of our PB is 9, and then the value of our PD is 25. Let us find now the value of our AP and then PC. So what we're gonna do is that AP times AP is equals to 25, which is the value of our PD, and then times 9, which is the value of our PB. So 25 times 9 is 225. Let us square both sides. So AP is equals to 15, while PC also is equals to 15. So we already have the value of AP and then PC. Okay, in example 6, we are using also the theorem 18, and it was already stated last example 5. So here, given that our AP is 5, 1, 5, and then our AC is 7, our BP is 4. So let us find now the measurement of our DB. So using this, So by using this, let us plug in the value of AP, which is 5 times the value of PC, which is 2. Since line PC has a value of AP and then value of AC, which is 5 plus 7 is equals to the value of PD, which is 4, and then times 4 plus DB, which is unknown. So, 5 plus 7, which is, we are using PIMDAS method. So, 5 plus 7 is 12. Then, 12 times 5 is equals to 60. And then, 4 times 4 is 16 plus 4 times dB is 4 dB. So, if we transpose 16 here in 60, so 60 minus 16 is 44. 4 44. So 44 divided by 4 both sides. So our line dB is 11. In problem B, by using this, okay, and the problem B, we have also the value of AP, which is 5. And then the value of our dB is AC minus 5. Now we also have the value of BP, which is 6. Let us find now the value of our AC. So AP, let us plug in the value of AP, which is 5, and then the value of PC, which is AC plus 5. Since our AC is unknown, is equals to 6 times 6 plus the value of DB, which is AC minus 5. So 5 times AC is 5 AC plus 5 times 5 equals to 25. Then in the other side, 6 plus times 6 plus AC minus 5. So first, let us minus 6 minus 5 is 1 plus AC. So 6 times 1 is 6, and then 6 times AC is 6 AC. So 5 AC minus 6 AC is equals to AC. And then 25 minus 6 is equals to 19. So now we already have the value of our AC, which is 19. In problem C, okay, in problem C, given that our AP is 6, this one, 6. And then in AC is 4. Well, in DP, the whole line is 12. Let us find now the measurement of this line PB. So we're gonna do is that input plug in the value of AP, which is 6 times 6, the value of AP, and then plus the value of AC. So equals 2 PB times 12. So 6 plus 4 is 10 times 6 is 60. Divide by 12 is equals to 5. So now we already have our value of PB, which is 5. So let us proceed now to our example 7. Okay, in example 7, we are using now the theorem of 20. So theorem 20 stated that if a secant and a tangent of a circle uh, intersects at the external point of the circle, then the product of the lengths of the secant segment and its circle is the external segment is equal to the square of the length of the tangent segment. So, given this problem, line CB is tangent to circle O at B. 1. So, and second segment contains O, then the center of the circle, which is this. So, let us find the following problem. So, in A, given that our CA, and since we are using the formula of our theorem 20, so given that in CA is 9, is 1, and then our CD, our CD is 4. Let us find now our CB, this one. So to find CB, let us plug in the value of CD, which is 9, and then the value of CD, which is 4. So 9 times 4 is 36. So CB squared, then let us square both sides. So square root of 36 is 6. So we already have the value of our CB, which is 6. Okay, in problem B, we are finding now the value of CD, which is this one, the CD in this pen. So, to find the value of CD, which we already have the given the value of CD, which is 3, and AD, just here, is 8. So, what we're gonna do is that CD times CD, which is CA has a value of CD and DA. So CD plus 8, which is the value of our AD, is equals to 3 squared, since the value of our CB is 3. So CD squared plus 8CD, which is CD times 8 is 8CD minus 3 squared is 9, so it equals to 0. So let us use again the factorial method. So CD plus 9 times CD minus 1 so equals to 0. Let us equate into 0, then CD is equals to negative 9 and CD is equals to 1. Why we reject negative 9? Since we don't have the measurement here were negative. So we already have the value of our CD, which is 1. Now let us proceed to our example 8. In example 8, we are using also a theorem 20, which is already discussed by Ma'am Diane, and I already stated it in example 7. So, a problem in example 8 is a secant and a tangent of a circle intersect at C. At the exterior of the circle O, the second segment passes through 0. The center of the circle and its external segment is 1 cm. Find the radius of the circle if the length of the tangent segment from C to the point of tangency is 3 cm. So, our 3 cm here is this one. 3 cm. Now, let us find the radius. And we have the given CD, which is 1. Since our CA cope up as line CD and then line AD. So, let us plug in 1 here as the value of CD times 1 plus 2 OD is equals to 3 squared. So, 1 times 1 is 1. 1 times 2 OD is 2 OD. So, let us transpose to let us transpose 1 here in 3 squared. So 3 squared is 9. Minus 1 is equals to 8. So divide both sides by 2. So we have already OD is equals to 4. So now we already have the radius for which is this one. OD, 4 centimeter. Okay, I hope this video can help you to understand the applications of theorems. Thank you and God bless.